So, welcome to Service Mesh Academy. We're going to be talking about Gateway API. I am joined today by Shane and Mattia. Thank you both for being here. We're going to go ahead and get right into it, but I will go ahead and point out things like if you want to go ahead and provide feedback, the platform chat should work, but you can also go to the workshop channel in Slack right there. But without further ado, because we have a fair amount of stuff to cover, let's go ahead and see if we can't get into it. This is just intent on doing the wrong thing. So one of the fun things about Service Mesh Academy is since we do this live, you get to watch everything break, like you just saw right there, where it put the wrong thing up for the screen share. Okay, yeah, once again, I'm joined today by Shane and by Mattia. Shane is a senior principal software engineer at Red Hat. Mattia is a software engineer at Kong. I'm a tech evangelist at Buoyant, but the real reason we're here today is that all three of us are involved in Gateway API. And Shane, Mattia, y'all want to talk a little bit about how you got involved in this grand experiment or mess or whatever you want to call it?
Sure. For me, getting involved in Gateway API was pretty early on. So end of 2019 and then really ramped up in 2020 when I was working at Mesosphere on a Kubernetes distribution called Convoy. And we were interested in the Gateway API because it was looking like a good successor to Ingress, which we'll talk about more.
Quite a bit.
Yeah, while I started getting involved in Gateway API when I joined Kong like a couple of years ago, 2.5 years ago. And yeah, I started as a simple contributor. Then I was more and more involved, and I eventually became maintainer of the Gateway API itself.
Cool. And I'm at Buoyant. When I showed up at Buoyant, I got told, hey, you should go check out this Gateway API for Mesh stuff. And I seem to recall that the moment my audio connected, Shane showed up saying, hey, Flynn, it's been a long time. And I went, oh, okay, well, I guess I'm getting involved now. It's been a fun time so far. The agenda for today is, on the one hand, simple, and on the other hand, possibly a little more slide heavy than some of our normal SMAs. We're going to talk about what Gateway API is and why you should care about it. We're going to do a demo, and then after the demo, we'll come back for gotchas and questions and things like that. It's going to be interesting to see how much time we have and how much we cover in the demo, because one of the fun things about Gateway API is that we can go on pretty much forever about it. So we'll see if we can manage that temptation. If you want to get following along by hand, the QR code there will take you to the GitHub repo that has the source code that we will be using for this. I'm going to be using Linkerd Enterprise 2.17. I think, I'm not going to lie, I'm actually just going to use whatever my Linkerd command on my laptop is running. So I think that's 2.17 right now. And the fact that I'm not too stressed about that should tell you that everything we're demoing is going to work with recent Linkerds as well. This is also wrong. I'm going to use a Civo cluster because that way Shane and Mattia can go poke at it. But pretty much any cluster should work as long as you actually have a working load balancer set up. And the reason that that is important is that we are using an actual gateway controller to provide Ingress into our cluster. It needs working load balancers. That in turn means that if you're going to use something like a kind cluster, you will also have to set up things like Metal LB or something like that so that you can have working load balancers. K3D clusters.
There are other ways, but it's
simpler.
Certainly the easiest way. Yeah.
Yeah, we should talk about some of the other ways actually, because the only way I've ever personally had this work is by using Metal LB. And I like Metal LB. It's fine. It's just extra steps for getting it going. So the stuff that we're using here, the stuff that the demo is kind of set up with, is you'll need kube control, you'll need K3D, you'll need BAT, you'll need Helm. I think you probably also need YQ in there. That should be checked as you go through this stuff. All right. And with that said, Shane, what
Yeah.
is Gateway API?
Yeah, we'll assume that some of you do know and some of you don't know what Gateway API is. So we'll kind of start at basics. As a project, it started within SIG Network, like I said a little while ago, in 2019 in San Diego. It was pitched as Ingress v2, but also potentially a successor to the Service API, which I imagine most of you all are familiar with as well. We reached GA in October 2023, right before KubeCon Chicago. And at this point, that means it's stable, but it's definitely not done. Like stable, but not slowing down much. There's still lots to do. We're just going to have backwards compatibility from this point on. We'll talk more about that as we get into other slides.
I would emphasize the definitely not done part.
There's a lot left to do. Yeah.
There's a lot left to do.
So backing up then a little bit more, before Gateway API was even around, we had Ingress, and there were some problems with Ingress. Well, the problem that Ingress tried to solve was, I am outside of the cluster ultimately, and I need to get access to a service inside of the cluster. Well, how do you do that? Well, by default, you don't. So you need something that does that. Ingress or Gateway API can do that for you and basically provide routing into those services in the cluster. But Ingress, which started out very early in Kubernetes and been around for a long time, still very widely used. Yeah, for a very long time, it was not even a matured API, but still very widely used. But it has a lot of very well-known problems. One of them being that it's monolithic. Everything's in one place. There's no separation of concerns. It covered a very simple scope and wasn't particularly extensible. Well, unless you count annotations, which we don't. We've often referred to that as we've often referred to Ingress as creating the Wild West of annotations, because maybe more so than any other resource in Kubernetes, if you looked at an Ingress resource, you might see just an absolute load of annotations on the resource for just with configurations that are specific to the implementation and so forth.
Since Ingress didn't define any mechanism that people were supposed to extend, everybody just leaned on annotations because it was what they had. And yeah, that made real problems if you wanted to change your Ingress implementation.
Lots of annotations, and then just lots of like custom whatever. There was no standard. So
yeah.
So moving forward then, 2019, Ingress API, we're looking at trying to fix those problems, among others. Standardization for the common capabilities is a big one. That's kind of the meat and potatoes of the whole thing, is that Ingress just didn't get far enough into common capabilities, and Gateway's trying to cover. We have a concept of a capabilities concept around core and extended capabilities. Core being the most important one. This is like every implementation should be able to do this, and that's the most important part of the standard, is that core of every implementation can do these things. That is still growing. The expanded scope, eventually we will expand the scope. Today, we're still actually covering the basics. So there are things that are beyond the basics that we're working on, but largely there are still basic HTTP things and gRPC things that we're still working on getting into the standard. It was basically on reflection of Ingress, designed for extensibility and has specific standardized mechanisms for extension. We'll talk a little bit more about those. And then it's role oriented. So separating concerns based on real world needs and the personas of real roles at play on clusters in the real world.
Do you have a quick example of a place where, you were talking about the basics for HTTP and gRPC, what comes immediately? What's the thing that you most want to see immediately that Gateway API doesn't yet cover?
Well, we just got timeouts. So that would have been what I would have said. I think today we're getting close. So I don't know that there's anything that's burning me right now. Backend TLS is a little high on my list. So that is the ability to terminate, like have TLS go to the gateway, but then like have TLS be different from the gateway to the backend service. That's pretty high on my list. Session persistence is really high on my list. Both of those are underway. They're just not there yet.
Yeah. We also have things like there are areas where HTTP has support for something, but gRPC does not, right? gRPC timeouts are not a thing yet, even though you can do HTTP timeouts, stuff like that. Yeah, there's some
basics that are still kind of, we're working
Yeah.
on them, and we're, you know, progress is pretty fast, but it's still coming along.
Cores is another one. I don't know that
And that's actually going on right now. Right now,
Yeah.
we're talking a lot about cores. So,
Yeah.
So
cores never makes me happy, but we need it.
right on. So Gateway API is a standard. So I'm kind of failing on what we were doing with this slide now that I think about it. Learn how a concept works, use it with whatever infrastructure you have. Okay, so yeah, basically like whatever infrastructure you have, basically Gateway API should apply. In fact, you'll see that platforms and stuff like that are increasingly just providing Gateway API out of the box. So things that are part of the standard that are widely supported, the core thing we talked about. We also have extended, which is not several, but not as many implementations can support these things. And in general, nothing gets to core certainly, and nothing gets to extended without several implementations implementing it. And importantly, Gateway API has done another thing that was kind of on reflection with Ingress. Ingress technically had conformance tests, but the whole situation just didn't end up working. Like we didn't end up really getting conformance reports and like actually know that people were conforming. It was all over the place, plus the annotation. So everybody had, you know, lots of custom features and stuff like that. We have proper conformance tests and then conformance reports that implementations actually send up to us in our repo and say, I checked this version of Gateway API, I ran these tests, here's my report showing that I support that, which is another really important thing that we learned from Ingress.
If I can say something on top of this, conformance reports are also very useful for users because it is meant to allow implementations to claim a certain degree of conformance against the API, but it is also intended to provide users a mean to check which implementation is better for them. So it's another purpose of the conformance reports.
Right on.
Yeah, we hear that a lot, actually, that the users do take advantage of the conformance tests in that way.
So today, the basics that are covered, and like I said, a lot of it's covered, not everything, but we cover HTTP and gRPC routing predominantly. This includes the basic stuff like routing a URL path to the service. We'll show some of that later. More advanced routing capabilities like route this URL path to service A if it has this header. Otherwise, route 25% of the traffic to service B and the rest to service C. Like things like this are expressible in Gateway API. We also technically have TCP, UDP, TLS. We have L4 routes, but these have been in experimental state for a long time, and it doesn't seem like they're going to be able to get out of that anytime soon because of what we said earlier, where we need people to come together and like bring conformance for these, and we haven't had implementations largely do that yet. So we'll see where they go.
Related to that, if you are interested in having standardized behaviors around layer 4 routing, you should come talk to the Gateway API folks so that we can hear about the use cases and we can start prodding on some of these things.
Absolutely. And then cores, we talked about cores. So there's some critical things like timeouts just went through, so that one's good now. But cores, and there's session persistence. There's a few other things that are coming along. So we already kind of covered that. But we're iterating quickly. We do multiple releases a year. We want to be able to do at least 3 releases a year with major features in them. It won't always turn out that way, but that's usually our goal.
We actually have a major release coming up
any day now.
Yeah, any day. I was going to say
time for KubeCon London.
Matter of weeks.
Yep. That'll be 1.3.
Gateway API 1.3. Yeah.
And then the other thing we talked about that like we learned from Ingress, extensibility. Gateway API was designed to allow extension where necessary. So for all the things that we can't fit into core or even extended, or for things that just don't even really seem to fit in the spec at all because they're very specific to an implementation, we call that implementation specific, we have extension refs, and we also technically have policy attachment. However, and we'll talk a little bit more about this later, in general, we advise people to avoid policy attachment when they can. But we do have these mechanisms there's caveats to it is the reason for that. But we do have these mechanisms in place to basically help provide a little bit more standardization about how you take something that's wholly implementation specific and plug it into the standard APIs.
And we will be talking a little bit about policy attachment, but we're not going to talk about it in great detail because the three of us could easily spend this entire workshop period talking about policy attachment, and let's not do that.
Yeah, it's a big topic.
Yeah.
Okay, so Shane started when he was talking about the Ingress. He mentioned an aspect of Ingress, which is his monolithic nature, right? While the Gateway API has been designed to be role-oriented. But what does role-oriented actually means? Well, basically, when you want to provide your service to some user, basically, there are multiple people involved, right? Because there is Hannah, who is the application developer, who is basically the person in charge of writing the application and deploying the application in the cluster. Then you have Chihiro, who is another person, because Chihiro is in charge of basically exposing the applications created by Anna outside the cluster boundaries. And then you have a third person, which is Ian, who is the infrastructure provider. Basically the person in charge of creating your cluster and dealing with the whole infrastructure. And finally, you have the user, which is basically the final goal of your application, right? Because there is a user who wants to access the applications that you create and deploy in your Kubernetes cluster. So as you can see, there are multiple persona involved, and Ian, Chihiro, and Hannah, as we said. And basically at each layer, we have different set of resources and set of concepts to deal with. For example, Ian, who is the person in charge of dealing with the cluster provisioning and the gateway controller management, is in charge of creating the gateway class. The gateway class basically is nothing more than just an abstraction of a gateway controller. So basically a gateway controller reconciles a specific gateway class. The gateway class is used and referenced by the gateway, who is the resource that is handled by Chihiro. And in order to connect a service, which is basically your application, to a gateway, Anna has to deal with the routes. So there are two routes which are standard at the moment, HTTP and gRPC route. But as we said before, there are multiple additional routes that are just in an experimental state yet, TLS, TCP, and UDP. And so, yeah, Anna creates the service, creates the backends, and connect their service to the gateway through the routes, so that basically the user can access the application from outside the cluster. Cool. So is there any role that is more important than the others? Probably yes, because without an application, you wouldn't have a Kubernetes cluster, because what's the point of having a Kubernetes cluster if you don't have any application to run, right? So the person that we are trying to focus more at this moment is Anna, because we want to facilitate Anna's life, basically, and Anna's experience in exposing her applications outside the cluster.
Yeah, nobody runs Kubernetes just to say they're running Kubernetes. They're always trying to accomplish something.
Yes, exactly. And yeah, as we skimmed very quickly, we have a few resources. The first one is the HTTP route, and on the right you can see a simple snippet of an HTTP route. And there are some important pieces in place that we want to take a look into. The first one is the parent, because as we said, the HTTP route is nothing more than kind of a conceptual wire between your service and the gateway. So the HTTP route has to reference a specific gateway And this reference is performed by the parent refs. So as you can see, we are referring the kind gateway, name, face gateway. And that gateway has to match the hostname smiley.example.com. So you can perform a hostname matching here. And you also have to set the backend ref, because as a wire, the HTTP route has to connect the gateway to a backend, and the backend is provided and provisioned by ANA. So we are referring to a Kubernetes service named Smiley on port 80 for this specific HTTP route.
You can use different types as backends, but I don't think there are no other core backend types, right?
Yeah.
Just service.
Yeah, this is actually where the extendability mentioned by Shane kicks in, because you could have multiple types of backend refs. So this aspect is extensible, but the only core backend, supported core backend, is a service. Yes. Oh yes, and also you can have multiple backend refs. So you can have two different services, and you can load balance your traffic between the Smiley and Smiley 2 services with 50-50 ratio. Also, this is not specified here, but you could customize the ratio between the load balancing. So you could set, for example, 30 to Smiley and 70 to Smiley 2, or add some other backend refs, and make this load balancing even more complex.
If we have time, we can show some of that too.
Yeah. And also, there are multiple kind of matches that you can set in your HTTP route. For this specific example, we are setting path matching. So basically, all the requests that match the path /good/path basically hit this specific rule and are routed to the specified backend.
So there's a lot you can do with this stuff.
Yeah. Well, of course, the path matching is only one kind of matching. We have also method matching, we have header matching, we have multiple kind of matching. And pretty the same thing is with gRPC route, which is intended to basically provide kind of the same functionality as HTTP, but focused on gRPC traffic.
And I just cannot let this stand, because this is my mistake.
Whoops.
Like we were saying, gRPC routes are optimized for gRPC.
So basically,
you cannot just stick a method match into an HTTP route and have it magically become gRPC. So yes, that's on me, guys.
Yeah. And also, as we said, along with the HTTP route, we have the concept of gateway, and the gateway is managed by Chihiro, who is the class provider. And the gateway, basically, this is the possible simplest gateway that you can create, which basically reference a gateway class named Ingress -gateway-class. It specifies only one listener for protocol HTTP on port 80. And all the routes from all the namespaces are allowed to connect to this specific gateway. So basically, with that field, you can basically narrow down the set of namespaces or the set of routes that can connect to this gateway. But for this specific one, all routes allowed from all namespaces.
And if you don't say that, if you don't have an allowed routes stanza at all, the default is that only routes from the same namespace as the gateway are allowed, right?
Yeah.
Yeah.
And so, the third one is the gateway class, which is operated by Ian. It's very simple. It's like the kind of the same of the Ingress class, with a subtle difference. because for the Ingress class, an Ingress controller has to match the Ingress class name, while for the gateway class, we have to match the controller name specified in the gateway class. So basically, a gateway reference is a gateway class, and that gateway is reconciled by a gateway controller if the controller name matches the one selected in the gateway controller. And yeah, this is basically the reference that is set in the gateway class name.
And pretty often, as an application developer, you don't have to think very much about gateway classes because that's somebody else's job.
Yeah.
But you will have to notice, pay some attention to gateway names.
Yeah. As we said, yes, also there is the third point, which is parameters ref. It's like an additional parameter to customize your gateway configuration with implementation-specific fields and configuration bits, basically.
Which we will not talk about.
Yeah. And so, yeah, this is a wrap, I guess, in relation to our main objects of the Gateway API role-oriented aspect. So you have your gateway class, gateway and routes, HTTP and gRPC. But we have additional resources that I guess we are going to talk about. Yes. The first one is the reference grant. Basically, if you create an HTTP route in a namespace named faces, for example, you can theoretically reference to a service who is living in another namespace. In this case, the namespace where the service is located is magic-namespace. And this reference is by default disallowed. So if you create just the service in magic namespace, and the route in faces namespace, it doesn't work because you have to create an additional resource, which is called the reference grant. And the reference grant is this kind of a resource that you have to create in the same namespace as the service. So it's the magic namespace. And in that reference grant, you have to explicitly allow all the HTTP routes coming from the namespace face to reference the object service in that specific namespace. So it's a way to explicitly allow cross namespace references, and it works for the backend referenced by the routes, and it should work for the routes referencing a gateway, if I'm not mistaken. It's intended to be used for those two specific purposes.
I'm not going to lie. The way I deal with reference grant is to never use them, and just to put things in the namespace where it's most useful.
Yeah. Just create everything in the same one.
Yeah. Shane, I think, had a couple of things that he wanted to add about this as well.
Yeah, Shane is saying that some implementations don't support reference grant because it's technically considered beta. This is true, but I'm afraid that this is part of the core test in the conformance suite. So basically, if you are not implementing the reference grant, you cannot claim core conformance for Gateway API.
What do the implementations that don't support reference grant do with cross namespace references?
That I actually don't know if we can say with certainty, because you're supposed to just implement it. But I think the other point that I was bringing up that I think is maybe a little bit more interesting for the audience is that this kind of allowing a reference through to another namespace actually ends up not being a thing that only networking needs. It actually ends up being a pretty common need. So and actually this is part of the reason why it's still in beta and not V1 is because we're anticipating the core API, and we've been working with API machinery and upstream. We're anticipating the core API actually having this functionality at some point and it not needing to live in Gateway API. So at some point in the future.
It's definitely a common problem in the whole Kubernetes community, for sure.
One of the things that we haven't talked about yet is some of the complications with Gateway API being a CRD API, meaning therefore that you have to manage the CRDs and all that kind of stuff.
There's some
And
slides coming up for that.
and what Shane just said makes me really curious whether they're thinking of adding reference grant in tree or whether they're still wanting it to be a CRD API.
I
Because
think last we talked, the talk was about in tree, but things can change.
And will frequently.
Yeah. And the last one is a resource that Flynn and Shane really love, which is policy attachment. Policies are basically a mechanism that you have to affect other resources' behavior. So let's say you want to set up some kind of weird policy on your service. So let's say that you want to allow that service to be reachable only when the moon phase is full. So only when the moon is in its full phase, you can access that specific service. Well, you can do that with a policy. And it is worth mentioning that policy is kind of a template that is provided by the Gateway API. It's kind of a standardized approach. And there are two different policies. The first type is the policies that are implemented in the Gateway API, but also implementations can create their specific policies. So, for example, this incredibly useful moon phase policy belongs to the Gateway API community, and you should absolutely use it because it's incredibly useful.
I guess I should probably point out, as far as I know, the only place the moon phase policy exists is in this presentation. And
Yes.
I do not know of anyone who has actually implemented it. But if you want to use policy attachment to allow access to a service only when the phase of the moon is full, this is the way policy attachment says you should do it.
Yeah.
As noted,
it's a great idea.
This is something you should be cautious about. It is very possible to create very, very confusing situations with policy attachment. And in particular, if you're talking about something that Anna has to do fairly often, it's probably not the first thing to reach for if you're trying to design extensibility into systems.
I could see this policy being like legit for maybe support services for turned werewolves.
Well, yeah, I mean, that's obviously, and of course, now that we've talked about it, somebody I'm sure is going to run out and implement the moon phase policy.
Well, actually, something that is also worth mentioning about the policy is that, as Flynn said, this is very powerful, but very complex mechanism, because let's say you create a policy and you attach the policy to the service, it's kind of tricky to understand, actually, to have a proper feedback of the policies affecting a specific service. So maybe something is not as you are expecting, and finding the root cause for that, it can be tricky, right? So it has to be used very carefully.
Yeah.
In defense of policy attachment, which is something that very few people have ever heard me say, there is a status mechanism that's defined to help provide that sort of feedback. But yeah, it can get really complex really quickly.
But the problem is that if you get just the service, you have no feedback about it. So if you just type kubectl get service, you have to figure out what are the policies that are affecting that service, right? Sorry, Shane.
Yeah, which you may not have access to. No, I was just going to add, I'm expecting there's probably two groups in the audience potentially. There are potentially people who would implement Gateway API. And for those people, what we said here, just do not just go create policies. Come join the community and talk to us about all the caveats and downsides first.
Please.
There may be another way to do what you're trying to do, and it may save you some pain. However, you may find that ultimately you need it, but it would be really good to make sure that you really are sure of that. And then for people who would use policies, kind of the same thing. Just because a policy is available, rather a policy type API is available, doesn't necessarily mean you want to invest in it. You might, but again, you might want to really dig in first because of these caveats, because of like who's going to be affected by the policy. Are they even going to be able to see that is a question you should be asking yourself, and how important is that to your use case?
In particular, if you find that your implementation has in fact implemented the moon phase policy, that should prompt you to ask a lot of questions of your implementation.
Yeah.
Okay, so a lot of what we've been talking about so far has been kind of from the perspective of Ingress, getting traffic from outside the cluster into the cluster. So this is Service Mesh Academy. So that raises the question of how does Gateway API interact with service meshes? This is the thing that I kind of got dragged into Gateway API to deal with. And the thing that's been interesting to look at and to discover as we've been thinking about this is that the concepts that we're talking about pretty much work the same way wherever you're talking about routing happening. So you could have HTTP routes and gRPC routes describing the way traffic gets routed from your gateway controller at the edge of the cluster over to your services. But those same concepts work equally well if you're talking about traffic between services. An HTTP route is still a relevant thing. What's different is not what the request is and how you should treat it. What's different is where the request gets presented. So Ingress traffic will arrive at a gateway, but mesh traffic will arrive at a service. And so if you change the parent ref for an HTTP route or a gRPC route or a UDP route or whatever, then all of these concepts still pretty much make sense. So where we had this exact HTTP route with a parent ref of a gateway, that would mean, oh, HTTP traffic arriving at this gateway with a hostname of smiley.example.com should go to the Smiley service. If we use a parent ref of a service, it means if traffic arrives at the Smiley service, then it should be with a hostname of smiley.example.com, then it should be directed to the Smiley service, which immediately raises a question of, wouldn't you get into a loop? And the answer is a little bit subtle, but there's a big distinction between traffic arriving at a service and traffic being forwarded on to that service. In Gateway API, you'll hear discussion of service front ends and service back ends. So this would be traffic arriving, traffic that somebody is trying to send to the Smiley service, meaning they're sending it to the front end of Smiley. And if the hostname matches smiley.example.com, the mesh will allow it to proceed to the endpoints of the Smiley service, the backend functionality. Implicit in this is that if it doesn't match the right hostname, we would drop it. Or we could go through and do path-based routing, or we could do canaries, or we could do header routing, and all that fancy stuff works exactly the same way. This is another thing we get to talk about in some length later. Also worth noting, the mesh may or may not support everything the gateway does. My favorite example here, it seems very unlikely to me that a mesh is going to support cores for mesh routing. I'm sure somebody can figure out a use case where you would need to, but it is not at all obvious what that would be. And this is also interesting because it implicitly means that the parent ref defines classes of traffic. So if you have a parent ref that is a gateway, you are talking about Ingress traffic. If you have a parent ref that is a service, you are talking about mesh traffic. If we want to do some new kind of traffic, like a new class of traffic for egress, we're pretty much going to have to do that by defining new parent refs. And that is kind of interesting to go through and look at all this stuff. Now, I'm not seeing a lot of questions so far, which is probably good. Mattia, Shane, do y'all think that there's anything we need to go back and talk about a little bit more before we get into trying to demo some of this stuff live?
I think we are set.
Excellent. Okay, our demo architecture. The demo this time is using an architecture that should be familiar to people doing Service Mesh Academy. We will, once again, be using the world famous Faces demo, which is, I'm sure, not world famous. But there's a QR code that will take you to its GitHub repo. The way the Faces demo works, and well, oh, wait a minute. I may have just missed something in chat. You know what? There's a question in chat that I missed. What are some of the reasons you would not want to use Gateway API for GraphQL? And while Shane and Mattia are talking about that, I'm going to figure out how to turn off the names in this so that the QR code is more readily visible for the next few slides.
I gotta see the chat question. Great talk. What are some of the cons to applying the Gateway API using GraphQL for Ingress? I don't know that I know enough about GraphQL to say that. I mean, I know enough to know that you could, but I'm not sure what the cons would be, to be honest, off the top of my head.
Yeah. I personally never heard of any problems with GraphQL.
I'm used to thinking, and it'll be fun to see. Let me back up a moment. If our questioner Tim knows more about GraphQL or knows enough about GraphQL to know why this is a naive point of view, I would love to hear more about this, right? But GraphQL, to my way of thinking, is fundamentally an HTTP API, but it does have different rules for the way you interpret paths and such than your typical REST thing. I don't think those rules are different enough to cause problems with Gateway API. And
wouldn't expect so.
I wouldn't expect so, yeah. Because if I remember correctly, there are still levels of hierarchy in the paths that refer to objects, refer to classes of objects, I guess, where you could meaningfully talk about what kinds of, hey, I want this kind of query to go over here. I want this kind of query to go over here. So I would be very interested in hearing if we are wrong about that. As a counterexample, we can point out that there has been much discussion about how you would use Gateway API for LLM routing, primarily because LLM routing, for some really depressing reason, puts the model name in the body and not in the header, and that is a real challenge in some situations.
Yeah.
But yes, none of us can think of anything, so if we're missing stuff, please let us know.
Yeah, the only thing I'm catching on a quick read is that, like maybe the way GraphQL doesn't work with like paths very much for its queries. So there may be some interesting things in how you do routing any particular query to any particular.
Is it headers or the query info?
That's what I'm curious about. But what I would actually say for Tim is, I don't think I've once heard somebody talk about using GraphQL for Gateway API, which is why we're all sitting here kind of curious. If you have a good use case, I would definitely suggest you go find an implementation of Gateway API, put your GraphQL database behind it, try it, and if you run into anything that's weird, doesn't work, or other struggles,
let us know.
Let us know on the github.com. Let us know on the discussions board on our GitHub repo for Gateway API. That would be good feedback. And maybe there'd be other people that would join you in that discussion and be like, actually, I'm trying to do this too, or I am doing this successfully. That'd be good feedback for us.
And I thought I had, so I'm pretty sure that if you go there, you'll end up getting linked through to the right place to open a discussion. Or of course you can show up. Actually, later in this presentation, Mattia has a slide about how to get involved, and that'll be definitely what you need. All right, back to the Faces demo. We start with a cluster and a web browser. The web browser is running a GUI, a single page web app, where the GUI will talk to the face workload running in the cluster. The face workload talks to Smiley and color. The Smiley workload is meant to return this smiley face. The color workload is meant to return this blue color. The face workload composites the two together, and that's how the GUI knows what to show in its grid. Each cell of the grid is a separate call into the microservices. The point here is that we have a microservices application, but we also have a call graph that's more than one level deep. So there are things where we must do it at the level of the Ingress or the gateway controller, and other things that we must do with the mesh. So this ends up being a useful way to kind of show some of the distinction there. We use HTTP between face and smiley, but we use gRPC between face and color. So this is a way to, it's a bit of a forcing function for HTTP route and gRPC route. We also have smiley 2 and color 2, and although they're not shown on the slide, we have smiley 3 and color 3, but we're not doing anything with those first. They're just there in case we want to use them to show off with. We have a gateway controller in between the GUI and the cluster. That is where our Ingress control is happening. And we also have a service mesh, Linkerd, handling all of the mesh routing inside of the cluster. And let's now get into the demo. We're going to do this a little bit differently here. We are going to start by assigning roles, and we are going to say that I will take the role of Ian, the infrastructure provider. Mattia will take the role of Chihiro, the cluster operator, and Shane will take the role of Anna, the application developer. And so we get to start with Anna wanting to run the phases demo in a cluster. So Shane, what would be the thing you would expect Anna to do at this point?
Well, if they don't have one, create a cluster.
But
But assuming
she
a cluster,
Yeah, so the first thing is she's going to come over and ask Ian, hey, I need a cluster, dude. And I cannot tell a lie. I have cheated a little bit in my role as Ian. I have already set up a cluster in which I have set up Gateway API and I have set up the service mesh. So we have a cluster that is ready to go. I'm pretending that Ian is doing a fully managed cluster in this case. So the next thing that Anna is going to want to do is what?
ultimately deploy her routes, or rather deploy her applications, and then get traffic into them.
And what does she need to get
She's
traffic?
going to need, with Gateway API, she's going to need a gateway by which she can attach her routes.
So this is the point where Chihiro gets involved.
Yeah.
And Mattia will talk us through what Chihiro is going to do.
Yeah. As a first step, I would ask Ian to provision a gateway class and a gateway controller, but since everything is already set up, I guess we can get started by creating a gateway. So as a first step, I would need to understand what is the gateway class installed in my cluster. So the gateway class is called Ingress gateway class, provisioned and managed by the the Envoy gateway controller. And then I can just create the gateway. So if we can take a look at the gateway, it's the very simple one that we already analyzed before, and let's apply it in the cluster. So
And the important things here, this has to match the gateway class that Ian created, right?
Yeah. And also another important bit is that the provisioning of a gateway implies the provisioning of a load balancer service. So once the gateway is created and correctly provisioned by the gateway controller, you are going to have your load balancer service that you can access and that you can use to expose your application.
Right. So let's go ahead and apply that.
And as a third step, we have to wait with a very verbose operation, our gateway to be programmed. And programmed means basically kind of ready. So it means that all the infrastructure has been provisioned. So it means that the load balancer service has been created and the data plane is ready to route your traffic and everything is in place to be used. And yes, you have an IP service, an IP address, which is 74, 220, 18, 19. And that IP can be accessed to reach the ANA application.
And while we were doing this, have any of us actually filed the bug for there needs to be an easier, cleaner way to do this?
I think we should do it. But by the way, this is just we, along with the Gateway API repository, we have a couple of additional tools which are called Ingress to Gateway, which is intended to migrate your configuration from Ingress to Gateway, and another one which is more on topic, which is called the Gateway Cattle. And Gateway Cattle is a tool that helps you to interact with the Gateway API resources in a more easy way, but unfortunately we lack a method to retrieve the state of the gateway. So this is something that we should do for sure.
We should,
and can be installed as a kubectl plugin, right?
Not yet.
Not yet. Okay.
Oh, I thought it could. Okay.
It will. It will.
Got it. And yeah, I did look to see if I could find something graceful in gateway control. I'm going to continue calling it gateway control. This is the real source of friction within the Gateway API community.
This is what takes up most
gateway
of our
cuddle
time.
or gateway control.
This is why nothing ever gets done, is because some people call it control when it's obviously cuddle.
So let's switch over to Anna's task. Chihiro says we have a gateway. Shane representing Anna. What's next?
Interestingly, so representing Anna, I am going to create a namespace. However, it might be interesting to note that might not actually be something Anna does on most or some clusters, but we're going to do that. Maybe assume, somebody gave you a namespace. And then we're going to add the namespace to Linkerd to make sure that everything within that namespace is part of the service mesh network. Again, might not actually be Anna, could be. Kind of depends on the situation. And that's one of the interesting things with the role-oriented kind of nature of the API design is like we define these roles, but there are blurred lines. And then ultimately, I'm going to go ahead and Helm install my Faces app. So this will put up all the pods and get everything running. And then we'll check it, make sure everything's actually up and running.
This is the part in these demos where I always worry because that always takes long enough for me to be concerned that it's not actually going to work.
And then, yeah. And then we'll go, it says it's up. Let's go take a look. It's not up.
No.
So why didn't that work?
We'll put Mattia on the spot. Mattia, you have any ideas? Anybody in Slack have ideas?
Maybe because you didn't create your route.
Yeah.
Right on. The application's deployed, yes, but nothing's exposing it. So we need to create a couple routes. So first route we're going to create is the GUI route. So this Faces app, which I only recently started taking a look at, but has the separation of the GUI, which is basically just delivering the HTML, web page, separate from the API. So first, we'll expose the GUI. So this is an HTTP route pointed at the gateway that Chihiro just created us, or Mattia just created us, saying, I have this route, and this gateway needs to ultimately program that route. And then the rules for that, which are /GUI, should ultimately go to the Faces GUI backend on port 80. And then the filters, which is just the Faces GUI app doesn't want that path, so we squish it down to the root path.
Yep.
So that will get to where we can just see the web page, but there's also an API. So this one, this is another route that will expose the API. Same thing, almost the exact same route, really, except this time it's /face. So we're pointing that one to the API and then squashing that down to the root path because the API doesn't expect a /face.
Yeah. Yeah, I was a little bit rude to both Mattia and Shane because I'm making them work with a mesh they don't work on, using a gateway controller they don't work on, and a demo app they don't work on. The flip side of that one is that the Gateway API parts are all the same as everything else they've ever done with Gateway API. So in a way, we're also demonstrating the whole transferable knowledge thing here.
Yeah, no, this is how it should work. 99% of the time, fingers crossed. Yeah. You shouldn't really have to understand the underlying implementation. Obviously, that's not always true, but
yeah,
ideally. Interestingly, I do know quite a bit about Linkerd, and I'm a big fan. But
Cool.
so we'll do. I'm not trying to like, but I do like Linkerd. HTTP route. So we've got our route. Both of our routes rather are deployed.
Only one route, actually.
Oh, only one route so far. So we're gonna go ahead and check the status of it. The status of the route will.
And
let
this
us
again,
know,
we should probably modify this so kube control will just show
make
us
it a
this
little
stuff.
easier. Yeah, there's some things we can make things easier. So it's accepted. So that just means like the controller that's taking care of the gateway, which is the proxy, ultimately the Envoy proxy. It said, yeah, that's my route. I'll take care of it. And then ultimately it resolved everything. And it's like, okay, that's programmed on the gateway on the data plane. So that's ready to go.
Resolved refs is also, like, oh, you didn't try to point me to a backend that doesn't exist and things like that, right?
Right. And then we'll expose the API as well. Check that. Same thing. We should actually be good to go now.
Let's find out.
Fingers crossed.
Ta-da!
We are online.
We're online. This is good. All right. Now we have a bit of a decision to make. And I think what we're going to do in the interests of time is let's go talk about things that are going well and gotchas and stuff like that. And then we're going to come back and do a little bit more routing demo stuff, just so we can prove that it's not just the gateway controller that does things with Gateway API in our demo. But before we do that, I want to emphasize a point that Shane made. What you just saw is the way this is supposed to work, in that if things are working correctly, the application developer really should not need to know what kind of infrastructure is going on and which pieces are implementing things. If you think about it, even Chihiro in this case didn't need to know what kind of gateway controller was there. Chihiro just needed to know a gateway class and a gateway class, so they could create a named gateway. Wow, I need to be more articulate about that.
You're good.
There are cases where Chihiro might need to know more than that. Like maybe the gateway needs some funky parameters ref for configuration, things like that. But ideally, Ian can go through and do his job, hand off to Chihiro, who does their job, who hands off to Anna, who does her job. And that's the way it's supposed to work.
If you were using just basic Ingress before this, then you should actually get you should be getting a pretty close to this kind of experience.
Yeah, and you should be able to use Ingress to Gateway to get started too while we're at it. Yeah. All right, so Mattia, stuff that's going well.
Yeah, many things are going pretty well at the moment. Gateway API is the most collaborative API in Kubernetes. We reached over 250 contributors and more than 25 implementations, something like that. Many contributors among many different companies, which is also a great thing because it's a very diverse community. Also, it's the first CRD API to be considered part of Kubernetes, which means that we already mentioned the fact that Gateway API is an out of 3 API, so it's CRD based, and it's the first CRD based API to be considered actually part of the Kubernetes community and project. It's mostly well specified and unambiguous, which means that in order to connect some resource, for example, a backend in order to expose a backend through a gateway, you have to be very explicit, as we saw before, for example, with the reference grant. In order to allow cross namespace reference, you have to be very explicit. You have to explicitly say that you want to cross the namespace boundary. So it's very well specified, a little bit verbose from time to time, but it has been designed to be robust, basically. And it's already much more feature rich than Ingress was. as we mentioned in the very beginning, one of the Ingress's problem was the annotations hell. So the Ingress core feature set was very small, and all the implementations added their specific features on top of the core Ingress features. While for the Gateway API, we have a way richer feature set that is natively implemented in the Gateway API itself, right? And also the last point is there is a community that is very active and ships faster than core Kubernetes. As Shane mentioned before, we are trying to ship 3 times a year right now. So we are trying to have a different pace detached from the Kubernetes pace. And yeah, we are trying to ship as fast as we can.
Shipping much, much faster than core Kubernetes. We'll let Shane talk about what's going less well.
Yeah. So it is going well. Things are going very well with Gateway API. You've probably, at this point, hopefully heard about Gateway API because of the successes that we've had. That said, anybody who's been in the industry for a while smells complexity here and knows that there's no free lunch. So there is this added complexity by definition, because we want it to be a more complete specification and stuff like that. And this comes with costs. And there are things that haven't gone well, things that need improvement and that sort of stuff. One of the things that we've been acutely aware of since GA and even before GA is that Anna's life with Gateway API, that is Anna, the application developer, has a tougher time with Gateway API than the other roles. And arguably, Anna is the most important role, so that is upside down. This is something that we're working on. We have some things coming down the pipeline that might improve. For instance, in Ingress, you don't have to know about a gateway. You can just say, here's my deployment, which has my application, here's my service, and then ultimately here's my Ingress to expose it outside of the cluster. And you can just kind of ship that to any cluster without having to know that there will be a specific named gateway on that cluster. That's something we want to be able to improve and create situations in which you can be a little less explicit. Now, we want to mostly be, like Mattia was saying, like mostly explicit, but when it's safe, provide things like that so that the application developer can just be like, yeah, here's how you expose my thing. I don't know anything about your infrastructure. That would be good. Use cases have been, HTTP route's been pretty solid, but outside of HTTP route, it's been very hard to really get good feedback on, even HTTP route, we could use more feedback, but good feedback on other use cases beyond the bog standard, I am using HTTP ingress. And that's something that we've struggled with and we're working on, but it kind of requires more people to come to the table to help. Extensions, while good, again, we talked about extensions being a good thing. There's a good side to them. They aren't as straightforward as we like. And one of the things that we've kind of realized is that we tried to avoid annotation hell. That is, annotations being used commonly amongst disparate annotations among all these implementations that there's no standard for. And now we have policy hell, effectively. Like it's arguably the same problem in a different kind of fashion. But there are good parts about policy as opposed to annotations in that, like, we actually have documentation on a rough standard for that within Gateway API. If you're interested in that kind of stuff, that gets in a little bit the weeds, but ultimately there's endless things to read about with this on our repo. And then this one's been kind of important. They've all been important to me, but this one's been important to me lately. We've struggled with experimental APIs. We had experimental APIs right from the get-go. And we intended them to be experimental in the way that you're thinking of experimental right now. But unfortunately, and we just didn't anticipate this, they've often ended up being kind of seen as more like, I'll say, staging or RC. At least some implementations have, I would say, almost gone out of their way a little bit to kind of make experimental APIs part of their GA, like part of their standard.
Well, they were in a tough situation where we've talked about how there were features that people need that are not
Yeah.
part of standard Gateway API. So those features would show up as an experimental API. The users would clamor for them, and they would let the users have access to them.
Yeah.
Which unfortunately is a recipe for teaching users that experimental is reliable and can be trusted, which makes it really hard to experiment.
Yeah. So that's where we're at, effectively, for all the reasons that I said and then Flynn added on. We're just in a place where experimental doesn't unfortunately mean experimental like we'd like it today, and that's something that we need to work on, because we need to really be able to experiment, rapidly prototype, and like build things. And that's something we've been talking about a lot in the upstream community. So
I feel like that also directly gets back to the point about use cases, right? To design APIs really well, you have to be able to provide an API, get some feedback from people who try to actually use it to do something, and then iterate.
Yeah.
And if you are also required to always be a perfect API designer and never make any backward incompatible changes, that's even more difficult than it would otherwise be.
Yeah. And so this experimental thing has been kind of a tough nut to crack, because we didn't anticipate some of these things happening. Now that they've happened, we're not like sitting there wondering how they happened. We kind of like, oh yeah, that happened because of this. But it's just one of those things that happens in API design, especially in highly collaborative API design, where it's like, oh, didn't really necessarily get ahead of the curve on that one. But there are ways to move forward and try to get what we want, which is to be able to have more of a truer experience of experimental, where you can move quickly and try things and stuff like that. That's been a struggle, and the getting people to test experimental part has been a struggle too, which is a great place. Anybody who's on this call who's just generally interested could potentially jump in. It's not, I'm not going to say it's an easy place necessarily, but it is. It's not like I could just go spend an hour in that, but it is a great place to jump in and get right into the thick of things. It's like looking at the experimental APIs, trying them, providing feedback, implementing them, what have you. So I think I have another page of things going less well. This first, it's really just two things, but we want to talk about them in some depth, because
we should have made this 3 slides.
Maybe these are important. So yeah, we should have done that. Lifecycle management of CRD APIs is currently very problematic. Now, this is not a Gateway API specific issue. This is a Kubernetes issue. CRDs are not exactly a first-class experience or rather, extensibility in general is not necessarily a first-class experience in Kubernetes. It has some odd ends. And Gateway API, since we were the first project to be an official CRD-based implementation that was officially part of Kubernetes, but is CRD, not part of the core API, we have learned a lot of them. We have walked the path and kind of cut the grass. So one of the things that we wanted to point out is that a lot of people today are actually kind of just as a part of whatever they're packaging are just deploying the Gateway API or CRDs. Please avoid that if at all possible. Actually, just please avoid that.
Because it will always be possible.
It will always be. Well, it depends. Platforms are changing on this, and I'll talk a little bit about that. Gateway API in practice is very much like a core API today. The mechanics are it's not actually one, but the reality is it's often treated like one, in that it's going to be available on a cluster, and we expect multiple implementations to use it. Whereas like a classic CRD might have been, this is for my specific application. Gateway API is very universal, very general, which introduces some interesting problems. Ideally, your actual platforms, like in the case I work on, OpenShift, we are going to be providing these for you. So OpenShift, in fact, will be providing Gateway API or CRDs in the next couple of releases here.
And will you be providing standard or experimental, or will that be a user choice?
Standard. Experimental will be an opt-in. So there's lots of upstream work to be done here, though. Like one of the things I personally care about a lot right now is I'm working with Azure and GCP for us and anybody else who wants to come to the table, but these are the ones I'm working with today. Platforms come together and make sure that we create a consistent experience for people deploying the Linkerds and the Kong gateway operators of the world on our platform. So it's not a different experience on every platform. And CRDs cause problems with this. So the interoperability between all these implementations is super important. CRDs present some challenges. And then one of the CRD specific challenges that might affect users that is when there are multiple implementations on the same cluster is what we call the unknown or dead fields problem, which is with CRDs, and this isn't really actually very specific to CRDs, but it comes up a lot in Gateway API. Implementations may know of a specific version, but a newer version might be present, meaning there might be a field that the user put there, and they have no reason to believe that field can't be used, and the implementation picked it up and threw it away, and that can be dangerous. We have an issue on this if you're interested. It's actually called unknown fields. We can link it, but suffice to say, there are some problems like this that are a little bit bigger when it comes to like things that come from CRDs, which we're working on and will need improvement this year. So
yeah, that can be a really interesting one. One of the things that we have found as we've dug into this is that the Kubernetes API server can do some very counterintuitive things if you start kind of poking at it about API versioning. It's tricky. Oh, and to explain a little bit why I was pointedly asking Shane if OpenShift would be doing standard or experimental, we are hearing from multiple cloud providers that they are much more likely to support automatically including the standard channel, which raises some more interesting questions about the experimental channel. So if you would like your cloud provider to provide Gateway API for you, which we would encourage, you might also want to poke at them and see if they can give you a way to do the experimental channel as well.
Roger that. So that all kind of begs the question, there are quite a few caveats, and it's not a free lunch situation. Should you be using Gateway API? At the top of it, if you're already using Ingress and maybe annotations and the service API, which isn't always a one-to-one like replacement with Gateway API, but you might just want to, you're fine. Those APIs aren't going to go away. They're going to be around forever. Well, forever asterisk, I guess, but very, very long time. Yeah, forever ultimately. And you don't need to go rushing off of them. However, if you just started a project, probably you do want to start with it because it's the new standard. It's where all new things are going. Ingress is not going to get any updates from here on out. Service will get as few updates as we can possibly manage.
Let's not even talk about service.
Yeah, well, that's a talk within itself. If you need features beyond basic Ingress, then this is a surefire thing. Like if Ingress simply just does not have the things you want, Gateway API for sure. And then more and more projects are kind of just requiring Gateway API anyway. So it may not even be a question of should you use it. You may just have to for some things. For example, Linkerd for service mesh. Flynn, just correct me or add on if I say anything wrong, but you will in fact just need to use HTTP route.
The way to do per route stuff in Linkerd is Gateway API.
Yeah,
ultimately.
Istio Ambient requires it, and then OpenShift, and I put an asterisk on there just to remind me, is kind of in a, well, it's not you have to use it to use OpenShift, but there are features in OpenShift that won't be available, like our OpenShift AI platform and some Ingress features that you'll need to use it for. However, you can still use Ingress and so forth if you need to. So suffice to say, projects, platforms are all moving towards it, and there's a lot of pressure to move to it. But you don't necessarily have to if you're sitting pretty with Ingress today.
Yeah. So as we mentioned before, the Gateway API community is very wide, is very diverse, but it's never enough, right? So we are always seeking for new contributors, new points of view, because every person who has different experience and background can bring something unique to the Gateway API. So
Absolutely.
There are multiple ways to get involved. The first and most obvious one is the Slack channel on the Kubernetes workspace of Slack. Then we have our repository, of course. You can get there, create an issue, start a discussion if you have something that you want to discuss, or maybe you have some use case, anything. For example, there was a message before about a use case with GraphQL. We are very interested in hearing more about use cases and what our users do with the Gateway API, because it's always a mean to grow and to get better as a project. Of course, there is the documentation website, which is gatewayAPI.6.kts.io. And of course, there is the last link related to this demo that has been provided by Flynn in the GitHub repository of the Service Mesh Academy organization.
Okay. With that, I'm going to race through a couple of words from our sponsor, and then we're going to go and do a little bit more on the demo side of the world. First up, please, for the love of all that is holy, scan the QR code, go fill out the Service Mesh Academy feedback so that we can make these presentations better. Yeah, really, please. It's a big deal. We really want you to do this.
It may seem like a chore, but it does a lot for us to
helps
understand and provide better content.
Yeah, so much. Shameless plug, the company that I work for makes Buoyant Enterprise for Linkerd, which is Linkerd and, has cool enterprisey things attached to it. Buoyant.io/enterprise Linkerd. It's actually pretty cool. There's some cool stuff in there. Check it out. You can do it for free. We have an online course. We're about to have another online course for Linkerd in production. And the next Service Mesh Academy is not in April. It is in May. In April, we'll be at KubeCon. Come say hi. Mattia, I hope you'll be there. I know Shane is going to skip this one.
Somebody bring me another Linky stuffy, please.
We can probably work something out there. Yeah. So in May 15th, we will be coming back to talk about Linkerd 2.18, which will be announced, well, hopefully before May 15th. All right. Questions? Hit up the chat. Hit the workshop channel on Slack. I'm going to take a couple minutes here to flip back and do a little bit more of a demo because I want to prove that we really do have a Gateway API mesh controller in here so we can really do mesh type things. I'm going to start that by using a mesh HTTP route to take all of the traffic being directed to our Smiley workload and instead unconditionally direct it to the Smiley 2 service. So the face workload is going to make a request that it sends to the Smiley service. Linkerd will catch that and redirect it to Smiley 2. And if I apply that, then we will immediately see everything shifting over to hard-eyed smileys because Smiley 2 returns hard-eyed smileys, where Smiley returns the grinning smiley. Something I want to reinforce here, actually two things I want to reinforce here. First, we didn't change any application code for this. This is all stuff going on the mesh. Second is it happened immediately. There is no restarting things. There's no, I don't know what else you'd have to do, but you put it in, it immediately happens. We can use our previous route status function to verify that yes, our route really was accepted, which is good. And it's easy to see how this would benefit a developer who wants to, say, test out a new version of the Smiley workload. And we'll talk more about that later. But another interesting case on this one is, suppose it's 10 p.m. on a Friday night and Anna is out doing whatever Anna does at 10 p.m. on a Friday night. And Chihiro down in the NOC starts to get notifications that something has gone horribly wrong. So Chihiro has the opportunity here to just go and change this to make the problem go away. And this has not fixed the problem. From an operational point of view, it would be a very bad idea to leave this kind of override in place because it will confuse people. But it can easily buy you a little bit of time so that you can deal with the problem during daylight hours and let your users have a reasonable experience. You also get to do things like canaries, where we will use a gRPC route to send only 10% of the color traffic to color 2. Mattia mentioned this one earlier. Color 2 actually returns a green color. So if we apply this one, we should see 10% of those blue backgrounds change to green. I will leave it as an exercise for the viewer what 10% of 16 is. But since we can go through and edit these things live, we can change the way that behaves. So we can change this to be a 75-25 split. And now we see more green. And then we can go through and change it to be a 50-50 split. And we should see a little bit more. And then just for the fun of it, it actually works to set one of these to 0, because that can be easier on automation sometimes. Because, of course, what I have just done is a manual progressive delivery scenario. And normally you would have a tool like Argo rollouts or Flux doing this, and they would just do it by editing the weights based on statistics. I should also point out that I carefully arranged for the weights to always add up to 100. You don't have to do that. The ratio is what matters. I just personally find it a little easier to think in terms of percentage while I'm editing this stuff on the fly. We can also do an A/B test. If we go back to the full browser, you'll see that there's a username up here. And this is set up so that I can change the username and log in as a different user without giving a password or anything. Terrible security, but handy for demos. So if I use this route in here, I can arrange it such that if I log in as Flynn, then my smileys will go to smiley3. Otherwise, they will go to smiley. This is not terribly obvious, but this is one rule. So this rule is, if we see a match for the header xfaces user having the value Flynn, go to the smiley3 backend. Otherwise, go to the smiley backend. You want to get really technical, there's an implicit matches clause in this one for matches anything. If I go apply this one, then I won't actually see anything until I go through and change this, and then things change immediately. And, you know, if I go through and log in as Shane, then I'm the only one who gets the rolling eyes. So this is the sort of thing that permits A/B testing. What's interesting about this one is that this is an A/B test happening deep in the call graph, because we're using the mesh with Gateway API for this rather than using the Ingress controller with Gateway API for this. I could configure an Ingress rule. I could configure an HTTP route that attaches to my gateway, but that would only be able to affect traffic going to the face workload, because that's the only thing the Ingress controller can see. Finally, another one that's kind of entertaining here is we've been doing this sort of implicitly, but there are 4 cells there. The edge cells all reference one path, and the center cells reference a different one for the smiley. So I can do a smiley rule that says all of the edge cells go to smiley3 while all the normal ones go to smiley. And if I apply this one, then we will see rolling eyes around the edge of the frame and not in the middle. I can do the same thing with the gRPC route using the method of the gRPC, where my center cells now will go to color3, which is supposed to return a dark blue. Otherwise, it will go to color, which is the light blue. I don't remember why exactly I decided to spell out the group and the kind and the namespace here. You don't have to do any of that, actually. So when I do this,
because again, it will default to service in the same namespace.
Yeah, in this particular case, I could have left it all out because it defaults to service. Yes. Now this is kind of interesting, because you'll notice that I said that the edge cells were supposed to give me the light blue, but they don't. And once again, Gateway API maintainers, why is this broken?
You tell me, man.
Mattia, any ideas? Anybody? Anybody from chat? No? It's broken because we already have a color canary route here. Our old color canary route, the one that I used to do that progressive delivery demo, has the color service as a parent, as does our AB or our AB split, our header, our dynamic routing split. Wow, I cannot talk. And this gets us into Gateway API's conflict resolution rules, which we haven't really talked about. But obviously, if you can go through and create routes wherever you want to, you can conceivably put in two routes that conflict with each other. That's exactly what's happened here. The method match on those central cells makes that part of this more specific, so it gets to win. But in places where they're equally specific, the oldest route wins, and the oldest route is our canary. The reason it's the oldest route is so you don't have random upstarts throwing in things that conflict and breaking your app or something like that, right? So if I bring back our browser here and I delete the canary route, then I start getting light blue out at the edges because conflict resolution. This is one of the trickier things that you run into with Gateway API, and it is definitely a thing that is worth paying some attention to and thinking about. The self-service nature of this kind of routing, where I, in my role as Anna Chihiro or anybody, I can just go and slap a route in and change behavior. This is enormously powerful, but with great power comes complexity and responsibility and things like that as well. So there's a lot more stuff that we could do with this. This is just sort of the whirlwind tour and, proving that the mesh is actually doing something. So with that, if we have any more questions showing up, now is a great time. I understand that Shane has to bail, but Mattia and I will field whatever questions we can. Although, we'll give it another minute or so, Shane, and see what we have. Oh, we may have one in the chat over here.
Yeah, I think we do have one.
HTTP and WebSockets. Oh, yeah.
I got another minute to hang around. There's a history with that one. So we do have app protocol, and you can define WebSocket. It's a little obscure, but we do have the ability.
It's very recent. I think that only showed up in 1.2, right?
Yeah.
So excellent. It's always nice to find out ways in which we got it wrong. But yeah, you can do WebSockets with HTTP route now. Anything else? We had a question in the Slack about traffic, however you pronounce that, and Gateway API. Traffic at least claims that they have some Gateway API support. I confess I have not personally tried it. So this is another one where love to get feedback on how that actually works out for people.
I saw them at a convention last year, and I'm pretty sure that they do, in fact. But I don't know that I've seen we can go look. I can go look. I can still stick around for another minute here.
Well, I went and looked on the Gateway API implementations page and then provided the link.
Oh, okay, cool.
Yeah. We can do that actually really quickly. The Gateway API has this lovely page that talks about implementations of Gateway API, and you can go through and click on various of them to see what they claim to support.
Roger that. And then here's their most recent conformance report, 121, which was, we were talking about that earlier, how we have conformance. You can go look at the implementations page, but we also have reports people can make for their implementations that say, this is, I support this exact version, and they've made one for 121.
And actually, there is a page in our documentation to make these reports more digestible. So if you go to here in the
so here we have one for traffic.
Yeah, so basically
3.2 supports a lot of stuff. Oh, we should pin this, huh?
Yeah.
We could always use web developers.
Yeah, absolutely.
We can all like.
So it does not support gateway infrastructure propagation, and it does not support HTTP route backend timeout and HTTP route parent ref port. And so, there's some features in here that it doesn't support, but I believe that all these features are extended rather than core.
Yeah, all the additional features, all the features listed here are extended. So basically, these are all the opt-ins in addition to the gateway and HTTP route profiles.
Yeah.
We
Yeah,
are
that page is
unfortunately at
helpful.
the half hour, and I had a great time. I do need to step.
Thanks for joining us, Shane. Really appreciate it.
Thank you for having me. Very much appreciated.
Absolutely. We'll do it again sometime. I
Cheers.
do not see any other questions, so I'm going to go ahead and drop this. Shane, don't let me keep you. He didn't let me keep him. Excellent. Mattia, thank you for joining as well. Any last commentary that you want to do before we end the stream?
Not really. Thanks to all the attendants, and thanks to you and to Linkerd.
Absolutely. Anytime. Glad to have you. All right. With that, we shall sign off until May. Thanks everybody for showing up. We really appreciate it. And we will talk to you all in May.